Welcome to helpyourmath.com. In this video, we're going to navigate the variables of statistics, specifically the formulas that involve populations and samples. So first, we use the capital letter N to represent a population size. This is the English alphabet regular letter N, but it's capital. This value will always be a counting number, and we use N when we can use the entire specified population. It's very rare that we're going to be able to use the entire specified population unless the population is very specific, such as the students in this statistics class who are here today. Then you could probably use the entire population, assuming nobody's in the bathroom or outside or anything like that. You would need to include every single person. If you wanted something like the adults in the United States, you're not going to be able to do a survey including every single adult. You would not be able to use the capital letter N for that. Instead, we would use the lowercase letter n to represent sample size. So we use the lowercase English alphabet letter N to represent when we're using a sample instead of a population. This value will always be a counting number, right? Because you can't ask 3.5 people a question. It would have to be 3 people or 4 people or 1,000,000 people, whatever the case may be. We use lowercase letter n when we have a representative sample of a specified population. And there's all sorts of biases in statistics that I'm sure you'll hear about, and you want to try to make it as accurate as possible when you are using a sample of a specified population. Next, we're going to look at the notation for summation. This is the capital letter sigma. This is a Greek letter, capital letter sigma, and it looks really scary, but it's really not that bad. A summation is a fancy word for adding up all the values in a set. It's used in formulas for both population and sample. So we see this uppercase letter sigma in both types of formulas, which is really unusual. Usually we have different variables, but this one's consistent. It frequently has a little equation under it and a single variable on top of it. So for a population, if we wanted to add up all of the data points in a population, it would look like this. So we have sigma, and then this is just the first result. This is the last result, and we include everything in between. And this is just saying we're going to add up all of these data values. So we would add up x sub 1 plus x sub 2 plus whatever plus x sub n. That's all it's saying. It's just a really short way of saying that that's for a population. For a sample, it's basically the same thing, but this time the top is the lowercase letter n, indicating that it's a sample. So this would just be, whoops, hold on, that should be a capital letter N there. There we go. So the summation, this would equal x sub 1 plus x sub 2 plus x sub 3 plus however many are in our sample plus x sub lowercase n. So that is sigma. Next, we're going to talk about the notation for the mean of a population. And while it looks like a letter U, it's actually the lowercase letter m in the Greek alphabet. And the lowercase letter m is actually called mu. So we pronounce it mu, like what a little kitten does. And it represents the mean of a population. To calculate the mean, that's where we add up all of the values and divide by the number of values. So the formula looks really scary, but it's really not that bad. This is just saying take all your data values and add them together. And then, just to calculate a mean, you divide by the number of numbers. You would be dividing by the number of the sample size, or excuse me, the population size. The notation for the mean of a sample is this. It's x bar. So it's an English letter X with a bar on top of it, and it's pronounced x bar. To calculate a sample mean, it's the same thing. We add up all the values and we divide by the number of numbers. So this is that. It looks really scary, but really it's not that bad. It's just a summation. And then we divide by the number of numbers, which would be whatever n is our sample size. Just a few notes. Sometimes we get a little bit lazy, or we just don't have the capability of making the sigma look like this. Sometimes we might also see it, and you'll see it later on because I was unable to switch it. It'll just have the I equals 1 here and the n up here, and then the x sub I over here. So that's another option. And other times we get even lazier and we just say the sum of the x's, where x is just every data value in the set. Next, we're going to look at the notation for population variance. This is sigma squared. Yes, we already had sigma. That was uppercase sigma. This is lowercase sigma. So there were 24 options for Greek letters and they chose to repeat one. How clever is that? So this is sigma squared. This value indicates to us how spread out the data are or are not. So there's a few different formulas that you can use. One formula is that sigma squared equals, remember what this is the sum of, and this is each data point minus the mean quantity squared. The reason we squared is just so that every value becomes positive, and that just helps us to create a sum and to actually show the variance, because if we had some positive and some negative, those would make it closer and closer to the mean, which would be a problem. So we take all of those and we divide it by n. Now, if you have to do this by hand, the best thing that you can do for yourself is to set up a table to keep track of all of this. And the notation for the sample size notation for the sample variance is s squared. So for the sample, we get to go back to our English alphabet, and it's s squared. That represents the variance of a sample. And again, what variance does is it indicates how spread out the data are or are not. One formula that we can use to calculate sample variance is given by this here. So again, interpreting this numerator, this is the sum of each data value minus the mean, and that thing squared. So if we have one data value of 2 and the mean is 7, then that would be a difference of minus 5, but then we square it, so we go to 25. We then divide by n minus 1. And the reason we actually subtract 1 for the sample is because it's a sample, there's more room for error. If you would do the entire population, there's a lot less error because you've already asked everyone. So as long as everyone was telling you the truth, there shouldn't be a huge problem there. But if we're just taking a sample, well, there's definitely going to be some error because it might be as representative as humanly possible, but that still doesn't mean it's going to be accurate. So by making the denominator smaller, that's spreading out the variance, it's making it a little bit wider just to account for the error since it is a sample. Now, usually we don't really care about the variances, variance. What we really care about is the standard deviation. And the standard deviation is just the square root of the variances. So the standard deviation for population is lowercase letter sigma. Again, it's a measure of the spread of the data, much like the range, which is a much simpler spread of the data. It tells us the average distance between any data point in the set and the mean itself. If you didn't have to do the variance formula that we saw on the last page, there's another formula that we can use. If you had to use that variance formula, then you can just take the square root of you can take the square root of the variance to calculate the standard deviation. Otherwise, if you didn't have to do that, there's another strategy here. That's to add up all the data points, add up the square of all the data points, and subtract it by, what do we have here? This is the sum of the data points, and then we're going to take that value and square it, divide it by the number of numbers. That's going to be, some value, probably going to have to round here, and then we're going to divide it by the number of values in the population, and then take the square root of that. So it looks really complicated, and again, I suggest if you have to do this by hand, set up a table to help you organize this information, because in a table, it's actually not that bad. And the notation for sample standard deviation, that would just be lowercase letter s. That measures the spread of the data. It tells us the average distance between any data point in the set and the mean. One formula, if you calculate the variance, just take the square root of the variance. Alternatively, you could use this formula here, where you add up the squares of each data point, you subtract it by the data points summed and squared, divided by the number in the sample, and then all of that divided by the sample minus 1. And again, that's just to account for the extra error. Hopefully this clears up any confusion that you might have had. I know it's a lot to take in. Review these variables as needed. On this slide, you'll find a summary of all the different notations we use for populations and samples.